Hi, today I'm going to present how to make networks with attributes, the ones with different colors and shapes. This is a step-by-step tutorial using Cytoscape, RStudio, and Excel. First of all, we need inputs. For a co-expression network, we can use an input like the one that PCIT gave us. That is the first one here. The output of PCIT have 4 columns. Each one of the elements in the first and second columns represent the elements in the correlations. And in the third column, we have the value of the correlation, and in the last column, the type of the correlation, if it's a positive or a negative correlation. But you can do other networks, not only co-expression ones. We can do EQTL networks or structural networks. In the EQTL networks, we only need 2 columns. So first of all, we need one with SNPs and another one with genes that are affected by this SNP. So SNP1 and gene 1, SNP1 and gene 2, and so on. For a structural network, for instance, in a factory, when you want to know how many employees are doing the same job and how are their names, or if there are a group of employees doing more than one jobs and all, you can do an input with 2 columns too, with employee 1 and job 1, employee 2, job 3, and so on. So you can use Cytoscape to make a lot of different networks, not just co-expression networks. Today, we are going to make this co-expression network. Actually, is a correlation network and not a co-expression network, because we don't have just genes in there or genetic elements. We have a phenotype there, backfat thickness here in orange. So we are going to do this network. That is one of the networks that will be in my paper. The elements or attributes that are marked here are backfat thickness in orange. In red, there is one gene that has its expression affected by a SNP associated to backfat thickness in my other analysis. 2 genes that show a correlation to backfat thickness in the PCIT analysis. 1 gene that contains the SNP associated with backfat thickness. And in pink, we have new possible regulators that show it after we did the network. In dark blue, we can see hotspot genes, or genes that are affected by more EQTLs than the others. The ones with the black contour are hotspot EQTLs, or genes containing EQTLs that affected more genes than the others. The triangles are TFs. So in order to do this network, we need an input, as we saw here, and another input containing attributes. In this another input, we will need information about phenotypes, genes that are affected by SNPs, correlated to the phenotype, containing SNPs, TFs, hotspot genes, and hotspot EQTLs. If you are going to do other co-expression network with other attributes, this second input will need to have all these informations. This is another example of a more complex network that you can do. This is another one for my future paper that shows the relationships regarding shear force that has more genes and more attributes. This one we will not do today because the computer freezes every 30 seconds because it's a more heavy one. And this is an example of an EQTL network. In here we can see genes and SNPs. So the genes are being affected by these SNPs. And the different colors are different GWAS windows. This is from Barbara's future paper. Just an example. So let's get started. First of all, this is, oh, not here. Sorry. Let's get started. So first of all, you need to open the Cytoscape software. And you need to put here your first output, the result of PCIT or any other software that you use to get the correlations among genes, and in this case, among phenotypes too. So you click here to import the input. We are going to use this one, input ready. In here, you need to mark your source column, your target column, your correlation column, and like an interaction type, positive or negative. If your file doesn't go there correct, you can click here in advanced options and change the delimiter, the default. If you don't have a header, you can click here and you will not use the first one as header. You can see that origin appears here. In our case, we want to start import at row 1. If you don't want to import the first rows, you can change it here too. Okay, so let's put here. Okay. So your network will appear in here. Depending on the number of elements that you have, this can take several minutes. In here it will not be a lot because this is not a so bigger one. Okay, this is your network. The first thing that we want to do is to see how many elements we have in this network, supposing that we don't know. So you go to Tools, Analyze Network, analyze it as direct graph. No, you want an undirected graph. We want it undirected. Okay, so if you look here, you have the table, the node table. Let's just export this table. You can choose the folder and the name, and we can see it here. It's better to see in Excel. If we see it in Excel, we can see a lot of statistics. All the genes are here, or all the elements are here. If you try to find your phenotype, it's here, okay? So all the elements in the network are here. And you have a lot of statistics about them. And one of the most important, the degree, or how many correlations does every element has in the network. So if you sort it for Z to A, or higher to lower, you will see that you have some genes here that make a lot of correlations, and some ones that don't make a lot. For instance, your phenotype, you can see that it only has 2 correlations in the network. Okay, this is important too. So what we want to do here, we want to copy this column, the names, all the elements. We can see here that we have 3,256 elements. Okay, so we will copy it to a new Excel one. We can change the name to Jeannie here. And what we want to do now is start to make the attributes. This is the way that I do it. You can do whatever you want. So first of all, I mark the phenotype. If I have one, I will mark the phenotype. So phenotype is here, so I make a column and, call it phenotypes. Okay, then we will save it, whatever you want, as PFT attribute. Okay, the attributes as txt. Replace? Yes, I want to replace in this case. Okay, so now we are going to the RStudio, and I have a script here in order to put all the attributes that I want in this table. How do I do it? First of all, I'm going to the folder that I want to do the analysis. Okay. Then I'm going to upload a list of genes and phenotypes that are in the BFT network, marking the phenotype. Or I will upload the folder that I just made. Okay. Let's see it here. Do you see it? Is the same. Yeah, it's the same file that I just made. Okay. Then I'm going to upload a list of genes correlated to back fat thickness that I pre-made. Let's see it here. So I have 2 genes that are correlated and I mark it as core. Okay. Then I merge these 2 files in order to put another column here, mark it as core. And the genes that are correlated to back fat thickness will have core in the row here. Okay, so this is a good command to use. It's a good function. So we choose the output name. Okay, it's the same one that I choose here because I just want to put it in the same folder, not to the same file, not to change it and have a lot of files here. Okay, so first of all, we choose the name. We use the function merge. Which files we want to merge? The one that we put it here at first, or this one with just 2 columns, gene and phenotype. Okay. The second one is the one with the genes correlated to back fat thickness. Here, 2 genes and core. Okay, so this first one and this one. By.x equal gene. What does it mean? By.x, or in the first object, which column do we want to merge? Which column will be the key to the merge? The gene column. If we saw here, the gene column is the one that have the names. And the second one, by y, okay? The one with the name gene 2. So, gene, okay? This column is the same one as this one with the gene names. Do I want all of the rows in the first file? Yes, I want all of the rows in the first file. Just want to mark them. Do I want all of the rows in the second file? No, just in the first one. So false here, true here. Okay, if we run it and look it in here, we have now another column. And if we see, mark it here, the 2 genes that have core or correlated to back fat thickness. So we are going to do this with all the attributes. So first, here, uploading a list of genes affected by a SNP associated to backfed genes. If we look here, we have just one and mark it as effect. So merging the same way, not changing the name. We want everything in this file. So when we look, another column, and here mark it the gene affected by this SNP. Okay? Then a list of genes containing the SNP. We have just one, two. Contain the SNP associated to backfed thickness. The name of the gene, mark it as contain. Merging it and looking at here, contain, and it's marked here. Okay? So now a list of TFs, merging it, a list of hotspot ETLs, merging it, hotspot genes, merging it, and then in the end we will make a table. First of all, we will see if everything is okay. Yes, we have our 7 columns. Phenotypes, correlated, affected, contained, TF, hotspot ETLs, hotspot genes. Everything is in here, okay? Then we make a table. How to make a table? We write table is the function, which is the object, this one, the file that we want to call in there, quote false, row names, true, call names, true, and the separation steps. Okay, so if you look here at 3B BTF TXT, we have everything here. And here is not the best way to see it, so we will open it in Excel. Okay, so open, browse, and 3B BTF. Remember that we could have some text problems, so text, finish. In here, the columns are not so perfect, so we just need to do that and change it. Okay. Then we have this lot of NAs in here. Just want them gone. So replace and go NAs to nothing, and voila, we have everything here. So if you see, we have marked everything here. Okay, but we have some attributes here that we want to make, to put different colors, and they are in different columns. For instance, phenotype, I want to mark in orange, and it's here. Correlated, I want to mark in green, and it's in here. And Cytoscape just let me choose one column to put one type of attributes. So I need to put all the attributes that will show the same effect in the network in the same column. So we can do something like that. I have it prepared here. It's the same thing. Okay. With the one that we do, we stop it here. Then we need to choose which columns we want to make the shape of the things in our network. Which columns we want to be selected to the contour of the shapes of our network, and the colors, and the size, and the label size. This is the type of things that we can change in our network. Shape, contour, color, size, label size. So we want to put everything together in the right column, okay? So shape. In our network, everything is round, but the TFs are triangles. So we want TFs here. So we can use something like this. 1F2, okay, here. Then we make something like that, and voila. Oh, it's not working properly, just like that. Yes, it's better. Let's erase these then you can see. F2, I want the column F2 here, okay? Then in here I want F3, F4, F5, so I just click here and it will mark everything here, okay? And the others with 0, and it's okay. Here the contour. The only elements in our network that have black contours are the hotspot ETLs, okay? So let's make this one. Okay, so you put G2. I want the G2, hotspot ETLs. Okay, and we'll mark, and so on. If you want more than one column, how do you do it? I will make this as an example. For instance, if you want something that will show the TFs and hotspot ETLs in the same type of attributes, so you make F2 because it's the column of the TFs, and you can put a separator here, okay, and hotspot ETLs is the G2, and you have both of them in the same line, same row, and you make something like that, okay, and it will appear here. Okay, this is the thing that I made here, okay, so you have everything here. Now you just want this part, not the others, so you select everything, Ctrl C, you copy it, and you just make the paste special, okay, just the values. So you just copy these in here. Now you can erase everything that you don't want. Entire column, yes. Now you have your attributes for shape, contour, color, size, and label size, okay? It's easier to work like that. Then you can save. How you save it? Like that, for instance. Attribute final. Okay? And what we do? So now we go again to the network. Okay, so now we want to import our attributes to our network. So we go here, import, table from file. We choose this one, where to impute to an unassigned table or to a network collection, okay? And then we can see a key here. This is important, okay. Now we want to make it prettier, so style, you can choose it here. I like this one. I think it's better to see everything. I want to start with this color. Then we can put everything in here. So first of all, the formats. I want everything to be round, but I want the TFs to be triangles. So I'm going here in shape, okay, shape, discrete mapping, and I choose triangles. Okay, you cannot see everything now, but it is triangle. Now the contour. The only things that have black contours are the hotspot ETLs. So border paint, contour, discrete, I will choose black. The others I don't want contours. You cannot see anything yet because you need to put a widget in the border. So contour, discrete, how many? You can put 10. You cannot see anything yet because you need to go here, view, always show graphic details. Then you will see everything. Okay, so everything is a lot of things. I like to change here for 1. It's the label font size. So it makes it better, okay? So everything that's wrote inside of these forms are very little now, so you can see everything. So contour and format, okay. Now colors. Okay, if we go to view color here, mapping, color, we have a column. Discrete, correlated. You choose the color. I will choose green. Affected. It's red. Oh, sorry, red. Contain. Light blue. Hotspot gene. Dark blue. And phenotype. Orange. Okay, colors are okay. Now size. Let's go here. Size. We have a column. Discrete also. So these ones we want 200. They contain, affected, correlated, 200. The other ones, like TFs and hotspots, just 70, it's okay. Here too. But the phenotypes, I want 300. Okay. Now the font size, the label size here. Label size. Discrete mapping. These ones I want 70 because I don't want labels for everything, just the more important genes. Otherwise I would not be able to read anything. So 70 and the phenotype 100. Sometimes it froze. Okay. So now I just want to make it better, like to put the things that are interesting to me in the right perspective. So here, this one too, it's correlated. Okay, this big one is the phenotype. You can make it like that, so you can select wherever you want. Make the goals whatever you want. Then again here. And it's already better. Not so much. Okay. Now you have some small ones here that are the ones that we call it probably new regulators because they are correlated to important genes in here. So we can do it like that. Select and bring it there. And these ones too. How to select a lot of genes at once? Like that. Okay, everything will be selected. Then you can drag them around. Like that. But you can make it better here. Then this one we can color it different. Okay, we can do something like that. Something like that. No, not like that. Something like that. Then we can go to fill color, and in here is the bypass. So you can choose colors outside of your attribute table. Okay, so I can put it in here and it will color just the ones in there. Okay, this is interesting too. Then you can change the label font size to 30, for instance. And also just need to wait for it. And the size to, where is it? Oh, size, here. Like this. Then another interesting thing that you can do is with the shift pressed, you unselected this one and you go to layout, attribute, circle layout, selected on, yes, here. And this will be rounded, okay? And this is the end, so you can just make it fit content. Everything will be shown here. Then you can export it to, export it to image. So you can save it, for instance, in SVG. You can change the name after. Export text as font. Yes, I want this. So, okay. And in the end, it will show here. And then your network will appear here. And that's the way that you make a co-expression network using Cytoscape. Okay, thank you.